So welcome you all for the online classes. After completion of the chapter magnetism and matter, so next we are going to start another interesting and important chapter. So that is of electromagnetic induction. So what is the chapter name is electromagnetic induction. Electromagnetic induction. So shortcut is very famous, which is EMI. Instead of remembering the total name, so EMI. This is the chapter. So unit number 6 in part 1 after magnetism and matter. Okay, EMI. So let me see the introduction for this chapter. Generally, so in magnetism and matter, so which one not magnetism and matter? Before that chapter, moving charges and magnetism, there we studied magnetic effect of electric current. What is magnetic effect of electric current? When current is passing through a conductor, around that conductor there exists magnetic field. In this magnetic effect of electric current, this is magnetic effect of electric current, magnetic effect of electric current. So current is producing magnetic field, which is moving charges or current. Because of the current, so magnetic field is producing. Magnetic field is producing because of which one? Current. So this is magnetic effect of electric current, chapter number 4. So that is discovered by the scientists in the year 1820. So scientist name is Ashok. Correct? That is, so that is Danish scientist Ashok. We know that magnetic effect of electric current, because of the current magnetic field is produced. Then everyone obviously so will get one doubt. Is it possible to get the converse effect of this? What is the meaning of converse effect of this? So because of moving magnet, here moving charges, current is nothing but which one? Moving charges. Moving charges are producing magnetic field. If I move the magnet, can it able to produce electric field or electric current? Electric current can be producible. Electric current produce agatte, so chances idea. So this is the concept, exactly the reverse effect of which one? Magnetic effect of electric current. So what is the reverse effect? Due to moving magnet, electric current will be produced. Does the nature will allow such converse effect or not? That is the question. Then after doing several experiments, so two scientists in the year 1830, so exactly nearly of 20 years later, 10 years later, in the year 1830, it is not 40. So scientist name is Faraday and Henry. So together they conducted several experiments. From that experiment, they concluded that it is possible to produce electric current because of moving a magnet. So they called this phenomena, then that time, so we called this phenomena as electromagnetic induction, EMI. Even in previous chapters, I come across many are asking for the running notes. Wherever you needed to note down the notes from this chapter onwards, I will tell. So note it down. This is definition important. Like that, every time after telling the definition, wherever you want to note down, I will repeat that the second time also, if you want. Okay, Nara? So that is now the very important definition for us. Many time asked question is for 1 mark. That is define electromagnetic induction. You don't write what is EMI means, electromagnetic induction. They know what is electromagnetic induction. Electromagnetic induction, EMI shortcut they know. You needed to write the definition. What is electromagnetic induction definition? So electromagnetic induction is a phenomena. First I am telling generally. So it is possible, everything is cannot able to write on the board. If I write each and every point on the board itself, I take the total time only for writing. Here not only for writing, I not here only for writing on the board. The thing is, you need to get the concept. I need to explain that. So that's why whatever the necessary points are required, so I will write it on the board. But along with that, if anywhere anything needed to dictate, so I will tell slowly, that time you can note down. So definition for EMI is very important. It is the phenomena in this phenomenon. So what happen? Whenever there is a change in magnetic field, simply first I will tell normal definition. Because of changing magnetic field, if the electric current is produced, that phenomena is called as electromagnetic induction. Okay, Nara? So because of changing which one? Changing the magnetic field, if the electric current is produced, that is called as electromagnetic induction. But when you write for the examination point of view, so then you needed to add the proper words. So proper effective words, then only, so that definition will be of proper definition. So electromagnetic induction properly can be defined as the phenomena in which whenever there is a change in magnetic flux linked with a coil. What is magnetic flux? We will come to know. Magnetic flux is representing the magnetic field. Instead of telling the magnetic field, so I am calling that a magnetic flux. The phenomena in which whenever there is a change in magnetic flux linked with a coil, an EMF induces and hence current will flow. EMF induced current will flow. So which current will flow? Induced current will flow in a conductor or coil, in a closed loop. Induced current will flow in a coil. Better I will call coil. What is the meaning of coil? Means one closed loop, a closed path for the flow of current is, can I call it as coil? So the phenomena in which whenever there is a change in magnetic flux linked with the coil, an EMF induces and hence the current will flow in that coil. That phenomena name is called as electromagnetic induction. This is the proper definition for EMI. Electromagnetic induction. So now if you want, you can note down. So what is the definition for EMI? Electromagnetic induction is a phenomena of in which whenever there is a change in magnetic flux linked with a coil, an EMF induces in the coil, hence the current will flow in that coil. That phenomena name is called as electromagnetic induction. Definition okay now? Normal words, it is nothing. Due to moving magnet, electric field will produce. So what happened? Change in magnetic field is producing the electric current, which is the converse effect of magnetic effect of electric current. Are you getting Ara? So that is given by the scientists Faraday and Henry. So okay now, when Faraday discovered that because of moving magnet, so near to a closed wire, he has taken a magnet which is north pole and south pole, and he taken one closed wire. Whenever a magnet is moving towards a wire, he observed in this closed loop some current. So first time he observed that. But when he observed, generally, if anything newly invented or newly discovered, many people around us, they will not accept, they will try to oppose and they will try to laugh also. They will try to discourage us. That is the common nature. So then when Faraday has observed this, so then immediate question is, what is the use of that? What is the use? Okay, you are telling that magnet is moving towards a coil, then so what happened? So current is generated in the coil. But what is the use of that? This experiment. Then immediately he has replied, this will be there a general story. So he replied that, what is the use of a newborn baby? Can you tell a baby so recently born? What is the use? Can you tell what is the use of that baby immediately? No. So when he has to grow, after many days or after many years, so he may become a doctor or engineer or a thief or anything. You cannot tell immediately what is the use of that person. So he also, that time he asked, he replied, what is the use? But later on, this phenomena was very, very, very important. Where we will come across this phenomena, so we will use this phenomena, so in generators, in so transformers. Nowadays you know that electricity will play how much important role. Without electricity we cannot able to so live our lives itself. That is the truth, everyone you know. So that electricity or transformers, you know that. So transformer, that working principle is this electromagnetic induction only. What is the thing is, when you invent or when you discover anything newly, you cannot expect the uses immediately. So compulsory, everything will be useful, 100% it will be useful. So nothing will be useless, but it takes some time. So someone needed to apply that concept, based on that concept, so application, you will get many uses. So that is the answer for this. Now, because this electromagnetic induction chapter is that much very important to this concept. Okay, Nana? So till now what I discussed, as per your subjective point of view, as per your examination point of view, so one more question we have covered. What is that one more question is? Define electromagnetic induction. So even they didn't ask till now, so who discovered this electromagnetic induction? But this asked question 1 mark many times asked. The magnetic effect of electric current discovered by the scientists asked. Okay, Nara? So now let us start our continuation, our topic. The first 3 marks question of this chapter now we are going to discuss. So that is Faraday Henry's experiments. Explain Faraday's and Henry experiments. So very important question, when many times given question for 3 marks in examination. So Faraday, simply they will call it as Faraday. So I will write, actually the proper name is Faraday and Henry. So together they conducted experiments, that Faraday Henry experiments. Okay, Nara? Explain Faraday and Henry's experiments, or simply they will also call explain the Faraday's experiments. These experiments very important. Based on these experiments only, Faraday has given Faraday laws of electromagnetic induction. The Faraday laws of electromagnetic induction was given based on these experiments only. They performed several experiments. In our syllabus there are 3 experiments are given. How many are there? So 3 experiments are given. So first one is, the first experiment name is, so this is called as coil and magnet experiment. Coil and magnet experiment. So, but remember, this question is not a definition. First let me explain briefly this experiment. So after explaining for your writing notes purpose, once again I will go through the description of the experiment slowly. That time if you want you can note down. First, what is this coil and magnet experiment? First one is coil and magnet experiment. The second one is coil and coil experiment. Even third one also coil and coil experiment only. So in this coil and magnet experiment, so what they considered is, they consider one coil which is connected to a galvanometer. What is the purpose of galvanometer? In order to measure the current. So what is the meaning of coil? Coil means what? A conducting wire will have number of turns, and the turns are insulated from each other. Such one is called as what? A coil. I consider one coil. Can I call this coil name is C1? This coil is connected to our galvanometer. Where? A galvanometer. So galvanometer, what will be there? In this galvanometer, so actually this is the galvanometer, will have a pointer will be there. Pointer will be there. Like we have seen, moving coil galvanometer, pointer will be there. The pointer will show deflection when current will passes. that a pointer will move on a scale which will give you the reading of current. That is the purpose of which one? Galvanometer. Now coil is connected to which one? Galvanometer. And they consider one bar magnet. In magnetism and matter you studied, every bar magnet will have two poles are there. North pole will be there, south pole will be there. If you cut the bar magnet into number of pieces also, every piece compulsory will have two poles. A bar magnet with a monopole will never be existed. And field lines directions are very important. Outside of field lines will pass from north to south, and inside field lines will pass from south to north. Magnetic field lines will form a closed path. Now they take it. So they observe that whenever a bar magnet is at rest, there is no deflection in the galvanometer. But remember, when galvanometer will show deflection, galvanometer will show deflection whenever current will pass. But when current will pass, let us check. So whenever, if they started moving the bar magnet towards the coil, whenever if they moving the bar magnet towards the coil, so what will be there? Magnetic field lines will be there. So field lines direction compulsory you need to mention. This is the direction of field lines. Field lines outside, they will come away from the north pole and they will enter into the south pole. So whenever a bar magnet is moving towards the coil, so what happened? They observed, so galvanometer showing some deflection. Galvanometer showing some deflection. Okay, Nara? So what they observed? Whenever a bar magnet is moving, what is the first point of this experiment is, if the bar magnet is moving towards the coil, so galvanometer showing some deflection. Okay, Nara? Which pole has started moving? North pole of the bar magnet. When it is moving towards the coil, I will write the coil names even here. Then what happened? So galvanometer showing some deflection. Why galvanometer showing deflection? Whenever bar magnet is started moving, the magnetic field linked with the coil is changing. Whenever a magnetic field is linked with the coil is changing, because of the phenomena electromagnetic induction. So what happened? So field is changing, current is generated. The deflection is because of the current. Okay, Nara? So that is the first point they observed. So again the second time what they did is, they started moving the bar magnet away from the coil. First time moving towards the coil and second time away from the coil. And first time when they started moving towards the coil and after some distance if they stop, there is no deflection. So deflection they observed until bar magnet is moving towards the coil. So after moving some distance, then they started moving the bar magnet away from the coil. When they started moving the bar magnet away from the coil, again what they observed is the deflection in the galvanometer, but in opposite direction. What is the meaning of direction opposite means? The current is reverse. Whenever a bar magnet is moving towards the coil, deflection is there. Whenever a bar magnet is away from the coil, deflection is there. But in both the cases, deflections are in opposite direction. Deflections are opposite direction indicating that the current is in opposite direction. Current in which direction? In opposite direction produced. Similarly, they perform the same experiment. So by taking the south pole, when south pole of the bar magnet is started moving, so towards the coil, then also they observe the deflection, but which is opposite to north pole. When south pole of the bar magnet is moving away from the bar magnet, again they observe the deflection that is opposite to, so when they started moving the south pole. Remember here, south pole moving toward the magnet also deflection is there. North pole moving toward the magnet also deflection is there. But current direction is reverse. When south pole, north pole moving away from the bar coil also deflection is there. When south pole moving away from the coil also deflection is there. But opposite in direction. What does it mean? It is your wish. You can move either north pole or south pole. But the current direction will be reverse. So this is the point they observed this. Okay, Nara? So, and the next one is fourth point. In this fourth point what they did is, Why should we move only bar magnet? So they keeping the bar magnet at rest and started moving the coil so towards the magnet. Whenever a coil is moving towards the magnet, that time also they observe the deflection. Whenever a coil is moving away from the magnet, that time also they observe the deflection. But moving towards the magnet, moving away from the magnet, the deflections are opposite, which are indicating that current is in opposite direction. What is the direction of the current? It is in opposite direction. So this is the first experiment for our syllabus, that is coil and magnet experiment. Okay, Nara? Now, those who are willing to write here itself the running notes, you can write it. So first Faraday and Henry experiment, coil and magnet experiment. So in this coil and magnet experiment, first what we need to consider a coil. This coil connected to a galvanometer, and consider one bar magnet. So then what happens? So let us move bar magnet, north pole of the magnet. So move the north pole of the magnet. North pole of the magnet is moving towards the magnet. You can write. So let us move the north pole of the bar magnet towards the coil. They observe that you should not write your own story. What is the experiment they perform? That experiment conclusions only you need to write. What they observe that whenever the north pole of the magnet moving towards the coil, they observe the deflection in the galvanometer. Moving towards, highlight points I am writing here. Moving towards the coil, they observe the deflection in the galvanometer. So whenever a north pole is moving away from the coil, north pole of the bar magnet is moving away from the coil, then also they observe the deflection in the galvanometer, but opposite in direction. First point over now. The second point is, so whenever north pole is over now. Second point, here I will write only together 3 points. So second point is, whenever the south pole, they started moving, south pole moving towards the magnet. Whenever the south pole is moving towards the coil, again they observe the deflection which is opposite to, so deflection due to north pole is moving towards the coil. So whenever south pole of the bar magnet is moving away from the coil, even this time also they observe the deflection, but which is opposite to when north pole is moving away from the coil. So that is the second step. And what about the third one? In third one, by keeping which one at rest? Keeping the magnet at rest. Magnet at rest. And which one is moving? When coil is moving towards the coil is moving towards the magnet, they observe deflection. So when coil is moving away from the magnet, coil is moving away from the magnet, so then also they observe the deflection, but opposite to when coil is moving towards the magnet. For your, what you need to write is, what is the experimental observations they have made. Only that experimental observations you have to write. Understood, Ara? So this is the coil and the magnet experiment of Faraday and Henry. Okay, Nara? So first experiment is completed. They may ask only one experiment for 3 marks. Together they won't ask all 3 experiments. They will ask, explain Faraday's coil and magnet experiment. Okay, Nara? Understood? Okay? Then after completion of this, the second experiment is given by coil and coil experiment. Which experiment? The experiment number 2 is coil and coil experiment. So what is this coil and coil experiment? Let us see. This is also Faraday experiments only. in this coil and coil experiments, so they consider two coils. This is coil C1 connected to galvanometer, and another coil C2 which was connected to a DC battery. This one name is C2. Okay, Nana? So this is the experimental arrangement for which experiment? Faraday and Henry coil and coil experiment. Okay, Nara? Then, so because of the connecting the battery to the C2, what happened? C2, the current will flow like this. But you know that whenever current is passing means around this C2, magnetic field will be there. Correct, Tara? That is only magnetic effect of electric current. So whenever C2 started moving towards C1, then obviously what happened? The magnetic field linked with which one? So magnetic field linked with C1 will changes. Field lines you need to write. And direction of the magnetic field, you know that whenever current is passing through a circular coil, the circular coil will act like a magnetic dipole. So north pole will be there, south pole will be there. Now what they observed that whenever C2 by keeping C1 at rest, fixed, C2 started moving towards C1. When C2 started moving towards C1, so they observed that there is a deflection in the galvanometer. Galvanometer is showing some deflection. Okay, Nara? When C2 moving towards C1 by keeping C1 at rest, so galvanometer showing some deflection. Why here galvanometer shows some deflection? The reason is when C2 moving towards C1, the magnetic field linked with C2, that is coupled with C1, is going to be changed. Whenever there is a change in magnetic field, then what happens? Due to the phenomena electromagnetic induction, so what happens? Magnetic field linked with C1 changes, current will flow. So what is the first observation they made? First you have to write regarding experiment description. They consider two coils C1 and C2. Coil C1 connected to the galvanometer and coil C2 connected to one DC battery. So after when current is passing through C2, the C2 started moving towards C1. So they observed that galvanometer showing some deflection. The reason is, so because of moving C2, the magnetic field linked with C2 coupled with C1 changes. Due to the change in the magnetic field, due to the phenomena EMI, though current will be there in C1. Then the second time they observed that same. Whenever C2 started moving away from the coil, first time C1 or C2? C2 is moving towards C1. Moving towards C1. Whereas here only C2 is moving away from C1. Is moving away from C1. In both the cases galvanometer shows deflection, but in opposite direction. When C2 moving towards C1, if the deflection, for example, clockwise, when C2 moving away from C1, deflection is opposite. The opposite deflection indicating that current is in opposite direction. The second thing is, so this time which one fixed for first one? C1 is fixed. By fixing the C1, so which one is moving? C2 is moving. Whereas the second time what they did is by C2 is fixed. Though current is passing through C2, C2 is fixed. So second time what they did? So C1 is moving towards C2. That time also they observed the deflection. Last time by keeping C1 fixed, C2 started moving towards C1 and C2 started moving away from C1. Whereas in the second time, so through which one current is passing? C2. C2 is fixed and C1 is started moving towards C2 and away from C2. In both the cases, when C2 moving towards C2, when C1 moving towards C2, they observe the deflection. And similarly, when C1 moving away, from where? Away from C2, then also they observe the deflection, but opposite in direction, which is indicating that when C1 moving towards C2 and C1 moving away from C2, the current is producing in which one? C1. So that current is in opposite direction. So understood, Ara? This is the second experimental conclusions. The conclusions made by Faraday and Henry from this coil and coil experiment. In this there are two coils are there, whereas in the first experiment, so coil and magnet. In the second experiment, the coil and coil. In first experiment, moving magnet is producing the current, whereas in the second experiment, moving coil is producing, so current carrying coil is producing current, or moving coil is producing the current. Understood, Anna? If you want to write the notes, so what you need to write? Consider two coil C1 connected to galvanometer. Consider another coil C2 connected to DC battery. Switch on the current in C2. When C2 is moving, by fixing C1, when C2 moving towards the C1, they observed the deflection in the galvanometer, indicating that current is produced in C1 due to moving C2. And when C2 moving away from C1, again they observe the deflection. So, but in opposite direction to the first case. Whereas in the second step, by fixing C2 constant or fixing by moving C1, so towards C2, they observe the deflection. Similarly, by fixing C2 constant, when C1 is moving away from C2, they again observe the deflection, but opposite to, so first time. This is the experimental conclusions, Faraday, Henry experiment. So these are the two experiments of Faraday and Henry. But from these experimental conclusions, we may think that, so here when current is producing, to produce the current, there is important point here. By observing these two experiments, we may understand that, so when current is producing, when there is a relative motion, what is the meaning of relative motion? In first experiment, which one? Coil and magnet. First time we fixed a coil, moving magnet. Second time we fixed a magnet, started moving the coil. Out of the two bodies, if any body is in motion, any one body at least, that motion called as relative motion. Until there is a relative motion between the coil and magnet. Relative motion between the coil and magnet means either coil is moving towards the magnet, or magnet is moving towards the coil, or coil is moving away from the magnet, or magnet is moving away from the coil. That motion called as relative motion. Until there is a relative motion between the coil and magnet, so there is a current. Understood, Ara? Whereas in this experiment, the coil and coil, in this coil and coil C1 and C2, first time we fixed C1 moving C2. Cross means fixed, right means moving. Then deflection is there. Second time we fixed C2 and started moving C1. Here also, if there is a relative motion between C1 and C2. Relative motion means, once again I am telling, both the bodies can move, or any one body at least should be in motion. When relative motion between C1 and C2, so there is a current is there. So from these two experiments, we may conclude that until there is a relative motion between a magnet and coil, or coil and coil, the EMF or current will be induced. But this conclusion is wrong. Relative motion is not compulsory. Without a relative motion also, so we can generate the current. That is third experiment. This is also coil and coil experiment only. Even this experiment also coil and coil experiment. So this experiment they won't give in many books. But to know the conclusion, the relative motion is not cause for the EMI. That's why I am discussing this experiment also. 2 experiments are enough for you. So this is also, let us see. In this also 2 coils are there. So one is of C1 which connected to galvanometer, but other is of C2 which connected to DC battery with the help of one plug key. With the help of which one? Plug key was there. Key. One plug key was there. So that is connected. Okay na? What is the difference? In the last experiment plug key was not there. Here plug key was there. But in this experiment both C1 C2 are fixed. So then what they did? So they observed that, so whenever this plug key was opened, or so plug key only na, plug key I can represent, okay, no problem, this is the indication for the plug key. Whenever this plug key was closed, when you are closing, when you close the plug key, so this is the first conclusion. What happened? Current in C2 is increases. So the current to increase, it takes some time. We will come to know why. Then when current is increasing, so that current is coupled, that because of this current, so there is a change in magnetic field will be produced. That magnetic field will changes when current is increasing. That magnetic field is coupled with C1. When magnetic field is changing, what happened? Current will produce according to EMI. Then galvanometer showing some deflection. But remember, so the deflection will not continue for long time. So then what happened? After some time immediately, so it stops showing deflection. It will show deflection until, so current in C2 increasing from 0 to maximum. It takes some considerable time, 1 minute or 2 minutes, to increase from 0 to maximum. But after some time when current increases in C2 maximum, so C1 will not show any deflection. Understood, Ara? So what happened? When plug key is pressed, plug key is closed, then what happened? There is a deflection in the galvanometer, a momentary deflection during plug key was closed. Similarly, they also observed that, so a momentary deflection which is opposite to when plug key is closed, when plug key is opened also. Whenever plug key was opened, the current in C2 decreases. It takes some time. During that time, magnetic field value, so magnetic field linked with C2 decreases. That field linked with C1 decreases. Due to that, current is there. So in both the cases, when plug key was opened, deflection was there. When plug key was closed, deflection was there. But both the deflections are opposite in direction. So what is the reason to show the deflection? When plug key was closed and plug key was open. When plug key is closed, so field linked with C2 increases, which is coupled with C1, causes to produce galvanometer deflection. When plug key was open, so current in C2 decreases, field linked with C2 decreases, that C2 is coupled with C1, decreases, galvanometer show deflection. There is no relative motion between, so C1 and C2. But though without any relative motion, current is generated. What is the reason here is, for generating the current, relative motion is not source. The main thing is, what should be changed? So magnetic field should be changed. The magnetic field will be represented by magnetic flux. So magnetic flux should be changed. This is the very important key. This magnetic flux may either increase or may decrease. When magnetic flux is increasing, so flux represented by phi. Magnetic flux should be changed. Then only the current will be generated. Our EMI is because of change in magnetic flux. Change means, remember, either increase or either decrease. Anything. Change means, don't think always increase. It may either increase or it may either decrease also. So that decrease, that change in magnetic flux is the source of generating the current. Conclusions okay now? If you want to explain this experiment, first let us consider two coils. So C1 connected to galvanometer, C2 connected to DC battery with a plug key. But remember, both should be placed near by near, not in touch, not in contact, but very close. Even so, after that what they did, when plug key, they observed that while closing the plug key and while opening the plug key, there is a momentary deflection in the galvanometer, which indicating that while closing the plug key and opening the plug key, the magnetic field linked with C2, which is coupled with C1, changes, which causes to produce the galvanometer to deflect. Understood, Aram? Even this deflection or this effect can be observable more by keeping a iron rod along the axis of this common axis of this C1 and C2. So this is regarding Faraday's and Henry experiments. Okay, Nara? Total together we discussed 3 experiments. Which one? So coil and magnet experiment, coil and coil experiment, and one more also, coil and coil experiment. Understood, Ara? So these are the Faraday and Henry experiments. So from these experiments, what are the conclusions? The conclusions of these experiments. Conclusions. They come to conclude that, so first point is, so whenever there is a change in magnetic field, this conclusion not required for you for subjective, but together I am telling that. So what are the conclusions? Whenever there is a change in magnetic field linked with a coil, or magnetic flux linked with a coil changes, EMF induces. Remember, magnetic flux linked with a coil, flux definition I will dictate it in the next one. Magnetic flux linked with a coil changes. So what happens? EMF induces, current will flow. And second one is, so if the change in magnetic flux is more, the induced EMF also more. If the change in magnetic flux is less, induced EMF also less. So if the magnetic flux change is more, change in magnetic flux is more, so EMF, electromotive force induced is also more. If the change in magnetic flux is less, EMF induces also less. But remember, magnetic flux should change around. What is the meaning of changing? Either increase or decrease. Magnetic flux should change, then only EMF induces. That induced EMF magnitude is more when magnetic flux change is more. That induced EMF magnitude is less if the magnetic flux change is less. Understood, Ara? How can you change the magnetic flux more? By moving the magnet or coil fastly or slowly. In first experiment, whenever a magnet is moving fastly towards the coil, they observe that deflection is more. So whenever a magnet is moving away from the coil fastly, they observe the deflection is more. Are you getting, Ara? So deflection depends upon, or current depends upon change in magnetic flux. The magnetic flux only change is the key role for what purpose? For producing the current or for generating this electromagnetic induction. Are you getting? So till now understood, Ara? This is what is the today we discuss for 4 marks. 1 mark 1 question and 3 marks any one experiment. Remember, not 3 experiments. And one more thing is, even writing the notes also very easy if you follow the class. Once listen the class, note on the side headings, and what are the points are examination point of view important, I am telling that. So that one you can note down while dictating. You can note down in class in a notebook. Okay. So this is regarding Faraday and Henry experiment and regarding the starting class of electromagnetic induction. Now in the next class we will discuss regarding, so what is magnetic flux, and what is Faraday laws of electromagnetic induction. So till now understood na? Okay na? So thank you.